Welcome to In Conversation, part of Telepresence, a cyber expo hosted by select rising thesis students of MFA Design and Technology program. It features 7 themes highlighting artists' individual explorations and examinations during the past year, all while exploring the potentials of non-physical communities. The 3 day workshop that we are holding includes a digital showcase, workshops, and artist talks. And today we are joining here to do this small little workshop called Hip Hop with Grasshopper. And we are going to be making these parametric dancing forms or towers that you see on the screen right here. And I'm going to guide you through the process of making these using the software Rhino and its plugin called Grasshopper, which is a computational design tool made for designers, architects, form makers, jewelry makers, anybody who is experimenting with computational design. And I hope to make it fun. We'll begin with a slight introduction about what Grasshopper is and getting through the interface and how you can work on it. And then I will guide you through the process of creating these towers here. I'm going to start by opening Rhino. I have Rhino 6 installed in my computer, but you could have anything above Rhino 5. And I'm sure you'd have Grasshopper coming with it. And those of you working on a trial version, don't worry, all of the functionality is available. So I'm not going to spend much time explaining the user interface of Rhino 6 because that's not what we are focusing on today. But just for starters, these are the different kind of views that you can see, and mostly we'll be working in the perspective view. So you can double click on this or out of this by double clicking. And let's open up Grasshopper. You would just type Grasshopper in the command line here, and it's going to start opening this up. It can be a bit overwhelming at the start to get used to working in Grasshopper, but once you practice enough or like go at it, and I'm sure after this workshop you're gonna find it enjoyable and hopefully start liking to work on it. Let's just start a new file, and I'm just going to briefly explain the working environment here. So Grasshopper works on components. It's a visual scripting environment in which you would put in components, think algorithmically, and think in steps about each of the things that you want to model. So for example, in Rhino, if you wanted to make a line, you are just going to get the line command. You're going to take one point and define another point, and boom, you have your line. But if you want to be doing the same thing in Grasshopper, you would have to use a line component and specify a start point differently and specify an endpoint differently. So I have these 2 points here. Now, how do I specify these points? It works with Rhino, so I can right click and say set 1 point and click anywhere inside here. I can do the same thing again, and it does it here. And then it draws a line. So now when you click on this, it becomes green, but this line directly is not editable in Rhino. You can't edit this line. But if you change the point, because you've set it in Rhino, that is editable, it's going to change the line. So all the dots that you see, like these here, not dots, the squares, these are all called components, and you could find a lot of them up here. So I currently have a lot of other plugins installed, and you might not have most of these, but you would have something until at least transform and display. So we are going to be working a lot with something called parameters. So there are these input parameters here, that's number sliders and panels or buttons, and there are math operations that you can do. There is addition, multiplication, division, or like maybe you can add scripts in there, or maybe if you want to work with domains and ranges, these are all the options that we have. Then there are different kinds of parameters and components for lists and domains, or like doing something with curves if you want to do different kind of curves or divide them or analyze a curve. They're like a lot of native Grasshopper components available for that. So, but usually when you're writing a script, you are not going to go up here and look at each of these icons to see what you want. So usually when I start working and I know what components I want to be working with, or like even if you have a brief idea of what you want, all you got to do is just double click on the screen and enter a search keyword. So if I wanted a line, I would type line, and it gives me all these options which have line inside of it. So I'm concerned with create a line between 2 points right now. So that's what I'm going to choose. And I would just want to briefly show a few different shortcuts. For example, for a number slider, if you want an input parameter called a number slider, you would usually find it under parameters, input, and the number slider here. And if you double click on this here, you can change the range of it. So the minimum value of the slider right now is 0 and the maximum is 1. But if you want to change it to say 10, you can just correct it, double click, write it here and say enter. If you want to change it to real numbers, or you just want it to be whole integers, or there are even numbers and odd numbers, so that's something that you can experiment with. So instead of going in here, I just double click on the screen, write a number, and that's automatically going to change it to a number slider. And I hit enter. So I get sliders like these. These are just some of the things that I wanted you to know before I start working on the actual GH definition for those dancing forms. And the way to connect to components would be you just left click your mouse and drag the arrow. So this is the output button here and this is the input here. Ignore this error right now. And most of the components, apart from the parameters, of course, will have both an input and an output. And sometimes these inputs are compulsory and sometimes they're optional. So like some of them have a default value set to it. So for example, this origin here has a default value of 0, 0, 0 set to it. So that's the origin point here. So I'll keep explaining all the components that I work with in the tutorial. But this is the basic working area of Grasshopper, and I'm gonna start with the workshop now. Okay, so let's get started creating our beautiful towers. We are going to need a base plate for the tower. So for that purpose, I'm going to be creating something using a component called Polygon to create a polygon. So now Polygon requires quite a few parameters here. The plane, which is locally, the default value is XY plane, so we don't need to change that. We want it to rest on the ground. We're going to change the radius to using a number slider. And then I'm going to edit the values here, make this 10 and make this a whole number because I don't want the radius to be in decimals. I'm just going to hit OK, take this up to 8 and join it here. Now a shortcut of creating number sliders is just double clicking, entering a number and hitting enter. So it's just going to give you a number slider just like that. So I want a triangle instead of a pentagon for now. And fillet radius is just going to curve the vertices. So I want something like 1.45. And I'm going to plug this in here. So it's going to round the edges for me, soften them down a bit, and you can adjust these values on your own. Now the next thing I want to do is I want multiple copies of these like as a floor plate of the tower. So what I'm going to do is I'm going to be moving these, and this is the geometry that I want to be moving, and I want to move them in the Z direction. So I'm going to use a component called unit Z here. Unit by default has a value of 1, so it's just going to move it by 1. But now since we want multiple copies of it, we are going to have to input number of numbers, so like a series of numbers. So I'm going to use a component called series here and then just attach it for now. So right now you can see that this is working with the default values that the series gives. That's from 0 to 9. But we don't want that. We want more values to play around with. So I'm going to use a number slider again and increase the step size here. The default value of step size is 1, but we need a larger one. So we might use 3. And then I want the count to be a little higher. So let's say maybe 15 plates rather than having 10 plates. So we have these 15 plates now. The next up, we're going to use a component called control points. You'll know why I'm doing this later on. So control points, and I'm going to input these curves. So right now the geometry is close planar curve. There are 15 close planar curves. I'm going to input them here. And what this component is going to do is give me the control point. So like if this was in Rhino, and if you wanted to be controlling the shape, how many vertices you'd need to do that. So that's what this component is doing. And now we want to scale all of these disks differently. Like we want to maybe manipulate their shapes and the sizes and the rotation. So for that purpose, we're going to be using a component called NU scale. So scale NU stands for non-uniform scaling of an object. And the geometry that we want to be scaling are these curves here. So I'm going to left click my mouse here and drag the arrow to geometry. And now the next parameter that scale NU requires is having a plane. So I'm going to find that plane by averaging these points. Since all of these disks are technically at a different plane, we can't be manipulating them on a single default plane of XY. So what I'm going to do is use a component called average and input the points here. So if I'm going to turn this on. So what this just did was gave a center point of each of these triangle plates here. So I'm going to input this arithmetic mean into the plane. So it's going to define the planes for all of these geometry. And now I want to scale the X and Y. So like I want to scale the dimensions of the disk. So this is where the cool part starts, and we actually start giving form to our tower. So what we are going to do is create a domain first. Create a range. Range is like it gives you a series of numbers from a starting point and an ending point. That's a domain. So domain is like 0 to 1. That's a domain. And the number of steps locally is 10. And it's going to give you 10 numbers between 0 and 1. So, but now we have 15 plates. So we actually need 15 numbers to be deforming them. So I'm going to attach this slider here to the steps. I'm going to keep the domain 0 to 1 for now. Now, the coolest part of Grasshopper, according to me, is this component called a graph mapper. What a graph mapper does is it takes in a set of values, like a range, and then maps them into different shapes. So let's see, we have a lot of graph types here, and maybe I'm just going to use sine for now. Okay, cool. I'm just going to use sine for now. And then I want to be remapping numbers here. So like using these graph values, then it's going to remap the numbers between a new numeric domain that's going to be specified by the source and target here. I'll get back to you real quick on that. And I'm going to input this mapped here into scale X and scale Y. So as soon as I do this, oh wait, let me just turn this off for a second here. And there's another thing that I forgot to do, which I'm going to do now. It's good. Now I can explain. Do you see the double rings here? That is because we originally had 15 disks. But this range here is actually giving us 16 numbers. And we don't want 16 numbers, we just want 15. So what I'm going to do is I'm going to right click on the steps, go into expression and put x minus 1 and hit commit changes. So the double rings are going to disappear then. And now I can be playing with these forms here. And it just doesn't have to be like, it doesn't have to be this particular graph type here. You can just go in and maybe say, I want a Bezier graph. I want to be changing this more definitively or like indefinitively, and you can do all sorts of things. But what you see right now is these deformations are limited to values between 0 to 1, and I maybe want to change that domain. So I need to specify the source and targets of remapping these numbers. So I'm going to use something called bounds here. So I'm going to input all these numbers, and what this does is gives a domain. So all of these numbers lie in the domain of 0.3821, and that is a source domain. And now I want to change the target domain. So what I'm going to do is construct a domain here. And Okay, input this in here, and I'm going to change the start and end. So maybe I want this as 2.45. So like the minimum dimension of each of my disk should be 2.45 and the max should be say 4.35. And if this is, yeah, this does look too big and disproportionate. So I'm just gonna decrease this to something that's more appropriate for us. Okay, now this looks good. You can experiment more with the graph types here. Sky's the limit. Do whatever you want to. There are a lot of different graph types. And okay, maybe I do this. Okay, cool. I'm gonna keep it here for now. And then maybe in the end, if I want to change the shape, I'll go in and do that. Okay, sorry, I'm playing too much. Okay, I'm just gonna keep it here. So we now have the form of our tower, and we are moving into the next part of the tutorial. Stay tuned. Okay, so moving on. We have our scale geometry here, and now we want to actually be twisting this tower. So I'm going to use a rotate component, and I am going to hook this geometry up here, change this angle to degrees, and I'm going to turn this preview off. So now we want to twist each of these plates by a different value. So I need a series of numbers for angles here. So once again, I'm going to use the series component, and I'm going to hook this in here. I'm going to add a different value for the step count, say 0.56, and I put this here. So now you see that it's starting to form interesting things. But again, there's a glitch here. If you see, only some of, not all of the plates are moving because we just have 10 numbers and we have 27 curves. So what I'm going to do is I am going to use the same amount of plates that we had. So I'm going to use something called a number parameter. Hook this here, drag this, and just hitch this on. So now we have 27 different numbers, and the tower is going to move based on that. Sorry for this. Okay. Yeah, I kind of like this form for now, so I'm going to stick with it. The next step is that we want to create our base plates. So like we want to create our floors. So this is now the section where we're going to start giving form to our tower. And now I'm going to use something called an extrude to extrude this towers as a floor. And I want the direction to be in Z direction. So I'm again going to use the unit Z here. And I want the floor height to be the same as the step size here. So I'll just make another number component so it's cleaner. Hook this here and wrap this. And yeah, okay. So we have it here now. But if you see, these are just open surfaces right now. They're not closed, and we maybe want to close floors. So there's actually a roof and there's a floor inside the building. So I'm just gonna hit a component called cap holes. So what it does is takes open preps and converts them into closed prep. So I'm just gonna turn the preview off on this one here and on this one too. Okay. So yeah, this looks good. And now is the time when we need those ribs that we wanted outside. And for that, we're gonna have to do a few steps. So this geometry here, which are the curves, I need them to be in the center to get reference points for those ribs. So what I'm gonna do is I'm gonna move that geometry in the Z direction. If you see, they are not exactly in the center of this floor height right now. They're somewhere in between, but I want it to be exactly in the center. So I'm gonna put it in a factor of 1.5. So that's the step size here, which was 3, like the floor height, divided by 2. So I'm just gonna put in that factor here, and now we see that these are exactly in middle of the floors. And now I'm gonna use something called an offset curve and offset these curves. So what offsetting does basically is take the curves and offsets them to a certain distance. If you guys are familiar with 3D modeling, you know what offset means. So I don't want all this distance, so I'm just gonna change it to maybe 1.05 or something. Let's see what that, oh, that was actually larger. Let's say just 1, okay, and reduce this to maybe 0.72. Yeah, but this looks good. Now we need these vertical ribs to be in the opposite direction, not this direction. So I need certain reference points for that, which I'm going to get by using something called a divide curve. And I'm going to divide all of these curves. Ooh, nice. So our ribs are actually going to be in this direction. So one would think that why shouldn't I just make an interpolating curve through this? So let's try doing that. I'm going to use a thing called interpolate here. And I'm just going to add these points here in the vertices, which is going to create those curves. You can see it's created these curves right here, like this way, in the direction opposite of what we want. We want these to be like perpendicular to the floor. So there's just one more step that we need to do here. We just do something called a flip matrix. So flip matrix, basically what it does is we have our lines here. So what flip matrix does, it inverts a list. So for example, if we have 1, 2, 3 here and x, y, z here, flip matrix is going to turn this to x, y, z, 1, 2, 3. So that's how flip matrix works, and that's exactly what we just did. So these points which were in this direction have now, the list has turned into the opposite direction. It's a difficult concept to grasp right now, and I do not want to go into the specifics of that, but our trick here is the flip matrix to get the ribs that we want. So we have these lines here now, but maybe I want more lines. I don't want such less lines, so maybe I'm gonna just increase the count of divide curve here and maybe take it to 30. Add this, and I'll just switch off unnecessary previews so it does not bother a lot. Okay. Nice. That looks pretty wild. But if you see, these curves are ending here. So like they don't go all the way to the top, or even at the bottom, they don't go all the way to the bottom. So I'm just gonna do a little small thing here. Add something called extend curve. I'm going to add this here, and I'm going to use was it 1.5? Yeah, I'm going to use this number here, 1.5. That was the number by which we displaced that curve. And start and end. Okay, so they have been extended now. And now we come to the final step of building up our tower. So we are going to use a component called pipe. That's the final step of building this tower. What pipe does, it's going to take in curves and build these pipes. So right now the radius is too large, so I'm just going to put the radius to something like 1.25, and let's see what's the default. Default is 1. Okay, so we want a number lot less than 1. So let's try with 0.22. Okay. Cool. And if you, let's see how much is the gap between, if you want to increase this distance, so we'll just go towards where we offset our curves and maybe increase the distance. So these ribs are actually outside the building and not touching the floor plates. And it can even be higher. So let's take this up to 2 and let's increase this a little bit here. Yup, this looks better. A lot better to me right now. Nice. And the final step is to add something called a custom preview, which kind of gives us a preview of the ribs and the breadth geometry. So I'm gonna pull this building here and add a hold down shift and add it to the geometry as well. Nice. Do you see something off here? I need to switch off a preview. Wait. Yeah, I'm gonna switch this preview off. Maybe turn this to rendered. And there we have a magnificent parametric tile. And this is called parametric because there are a lot of these parameters that you can change. So for example, you didn't want it to be a triangle and you want it to be something with 4 sides. Just change it. And it's gonna give you something wilder. Did it? Did it not? So maybe instead of using one graph mapper, you could instead use 2 here. So like add another graph mapper. So what it's going to do is it is going to add the values of both of them and give you some other cooked up values for your object. And like it's basically adding these 2 maps and giving you a set of numbers. So you can keep changing either one of these maps and change the domains and play with these parameters here. And I'm sure it's going to be lovely. There are a lot of forms that you can experiment with. I am going to quickly unhook the preview for now because I really want to change something. So maybe instead of 5 segments, so like a pentagon here, I maybe want something which is made up of hexagons. Did it change anything? Yeah, it did. Let's see how does this form look like if we just have 3 segments. It's gonna take a while. Yeah, got it. Doesn't look half bad. It's clunky, funky looking. I kind of like it. And also if you want less number of pipes, you can always go in here and change the number of divide curves. So right now it's 30, but that's too many. It feels like this on top of this one. So if I just hit it down to 20, it's gonna give me less number of ribs. And there's a lot of possibilities. But thank you guys. This has really been great. Once again, just as a reminder, I will be there on Saturday, that's 29th of August, to answer your live questions and be with you for an hour if there's something that you guys can come up with. And we can also be discussing things like other resources for you to get started on this, or the applications of Grasshopper, and how could you take this forward. I will be live on Instagram at MFADT from 11:30 a.m. to 12:15 p.m. on Saturday. Again, that's 29th of August. And I hope that you guys will join me in, chime in for a little conversation and interaction on this workshop. But apart from that, have a good day, have a good night, or a good evening, whichever part of the world you're in. Lastly, I want to thank all of you. Thank you, all the participants, for joining us and giving us an opportunity to think about things like this and work on new things and continue to develop our processes. As a reminder, this workshop is a part of Telepresence, a larger cyber expo, the beautiful website that's up on my screen here. And please feel free to go through this website. There are a lot of amazing works by a lot of amazing people up at my college. And there are plenty of other great events happening over the next 2 days. There are the workshops, artist presentations, and more as well. And you can view them on the events page here. Please visit mfadt.space to see the full exhibition of projects and lineup of events. Thank you for joining us this evening, and we look forward to seeing you throughout the expo. Take care, everyone.